This old dishwasher motor appears to be well within its rated load for this size of impeller, and I want to do some experiments with different shapes of impeller blades. I'm laying out arcs for the blower vanes, and I'm using calipers to consistently space the centers of the arcs. This will be the hub, and hopefully when I glue this on there I won't end up with a rotor that wobbles. I'll use a drill to center it, and now just gravity clamp it in place. That's pretty good. That runs nice and round, but I won't spin this up yet because these are just freshly glued and they might fly off. And it looks like it's a little bit out of balance. This one's too heavy. I didn't want to whittle away too much of the rotor, so I added a counterweight. Now I have to design the spiral for the housing. The arc is going to go from this radius to this radius as it goes around. So if we go from here and then we go to this radius, then this radius, and then this radius. And so I'm going to set my compass to about halfway between these two radii here. And then I need to find a point here where it joins these two up. Bring it in to halfway between this radius and this radius, maybe about this much. And once again, I gotta find a spot for the compass that meets those. I kept hitting the post of the bandsaw. My 16-inch bandsaw isn't big enough, but my big 20-inch bandsaw is in my other shop set up as a sawmill right now. Making the wall for this spiral housing has always been a lot of work, and so this time I'm trying something different again. I'll put these pieces on and I'll cut them out afterwards. Now I just have to wait for the glue to dry and then I can cut it out. I need to work out the geometry of these mounting holes, and I've already measured them and they're all equal distance of 111 millimeters, so I know this is an equilateral triangle. So to get the radius from the shaft to the hole, I can take this distance, 111 divided by 2, and that gives me this distance here. And to get this distance, I divide by 30 degrees cosine, because I know that angle in here is 30 degrees. So that comes up to 64 millimeters. And let's set the calipers to that. And that looks like it's right. Unfortunately, I already drilled out this hole, so I had to make a plug to put a compass in the middle of it. And one of the holes will go here, and I need to go 120 degrees to that one, and next hole goes here. And just to check, that doesn't quite work out. So I'm going to come from here out like this. When I looked at footage of this rotor spinning, I noticed some of the fins seem to be not quite on straight, specifically this one. So I was able to pry that off and put it back in the right place, and that made this counterweight almost unnecessary. It's tempting to spin this rotor up as it is, but there's so much centrifugal force on these fins that they might break off. So I need to glue this on, and every time I've glued one of these on, I've always gotten it off center a little bit, but I've had a cool idea for centering this. Is just to take the offcut, put that on the drill, and that serves as a guide for where I need to put this part. My goal with these experiments is to test an impeller that's typically found in the dust collector, which has got straight fins like this, against one that has the fins forward facing and backwards facing. And to actually make them face backwards, I'm just going to reverse the motor so that instead of this way, it goes that way, and now flip around the housing, and then I have a backwards facing impeller without having to make a new one. First test is with a straight finned impeller. Now let's switch that over to the forward-facing impeller. So what's interesting is this impeller only ran at 2,000 RPM versus 3,000 RPM for this, but the wind speed coming out was the same. So for the same RPM, this blows a lot harder, but it also needs more power. The next step is to switch to a backwards facing impeller, and for that I have to flip the housing, and I also have to reverse the motor. The way this motor is wired internally, I can't reverse it electrically, but I can reverse it just by flipping around the stator. $143 watts, 3215 RPM. This is noise level, straight impeller. This is noise level, backwards curved impeller. The numbers are less straightforward than I was hoping, because when I had the fins forward facing, the motor was way overloaded and it was only running at 1984 RPM. That's with the rotor going like this. So at that point, the efficiency of the motor drops dramatically. With the straight fins, the motor is running at 3052 RPM, still slightly overloaded. Interestingly enough, the airspeed coming out of the blower was the same for both, even though for the forward-facing fins, it was only running at 2/3 the speed. So that tells me if you're limited by RPM but not by power, you can actually get more airflow like this. Although in terms of static pressure at the lower RPM, that would be a lot less. With the backwards curved fins, the power consumption was a lot less. So just 74 watts over idle versus 213 watts over idle, so almost down to a third. The airspeed was less, even though it's running at a higher RPM. So you basically would need a bigger blower to get the same performance running it this way, but the static pressure that it was able to put out was greater with the backwards curved fins. So it would make sense in terms of efficiency to run the rotor backwards curved and just make it bigger, because it's so much more efficient that you can run a larger rotor with the same size motor. Now for the forward curve, this was really inefficient, but the motor is also running very inefficiently, so the lower efficiency going this way is probably not as dramatic as this would suggest. So now I can understand why sometimes you see forward curved fins and sometimes backward curved fins. The forward curved fins for the same RPM and the same blower size will give you more airflow, but probably less efficiency. And the backward curved ones, that's best for having a larger rotor with a small motor, and it also gives you the best static pressure. And of course the straight fins is a nice compromise between the two of them, and it's easiest to build. And it seems intuitive that forward facing would give you higher airflow. So I put a marble in here and turned this rotor, and it just whips it out like I was playing a game of Jai Alai. Whereas going backwards, if I put this marble in again and I turn it the other way around, it comes out much more slowly.
I hope this video was helpful for you. Please like and share this video.